Hello again, ladies and gentlemen. This is Mr. Smith, and this is 6.9, Volume of a Sphere. This should be the first lesson of the last week of lessons, going into our final couple weeks of class here. I will have stuff for you to do in the last 2 weeks of school, so don't worry about that, though. Okay, 6.9, Volume of a Sphere. Like the other volume lessons, it's pretty straightforward as long as you have the formula. And in this case, yeah, it's still pretty straightforward, but there's two different formulas, and one of them I like more than the other. So let's get started with the first one. This one I'm not a huge fan of. Oh, I already messed it up. This one I'm not a huge fan of, and there's a reason why. Once I get my pen back. Okay. And here's why. We have 3 over 4, or 4 over 3 times pi, 4 over 3 times pi r cubed. Now, it might not look bad. I just don't like multiplying a fraction by something. So here's what I do. I just put 4 pi times r cubed all over 3. And the math will work out, and this is my favorite way, so I'm going to star this. This is my favorite way to do this because you do your multiplication all at the top first, and then once you get your answer, you just hit divide by 3 on your calculator. Makes life easy. Life's already difficult enough. We don't need to make it more difficult on you, so just do it the second way. All right. Going into our next, or first example, sorry. We're just going to rewrite the formula. Volume equals 4 pi r cubed over 3. Now, we know what r is because it's given to us. It's 8. So we're just going to sub that in. 4 pi 8 to the power of 3 all over 3. Now, depending on your calculator, this button might look different. To do the power of 3, you would do 8 y to the x 3. You might have that button. Another button it might be is this button. It looks like a little hat. Sometimes it's x to the power of y. It'll usually be one of those two buttons though. So that's just a side. I'm going to erase that so I don't confuse people that are just reading this. So let's erase that. But those are the buttons that you would use to do 8 to the power of 3. You can write that down in your notes if you wanted to. You can always go back in the video and double check though. Okay. So you do 4 times pi times 8 to the power of 3 and then equals and then divide by 3. Most calculators will let you do that. And you should get 2,144.7 centimeters cubed. Okay? If you didn't get that, don't worry about it. We have another example coming up, and I'll let you try it there. I just wanted to demonstrate what it was. So in our next example, we're actually given the diameter, so we actually need to figure out what is the radius. Well, diameter equals 2r. We know diameter is 5 equals 2r. Divide both sides by 2, and we'll get what r is. 2.5 equals r. Okay, so now we can actually just sub that into our formula. I'm going to rewrite it. V equals 4 pi r cubed all over 3. Now I can sub in the numbers. 4 times pi times 2.5 to the power of 3 all over 3. Now, when you plug this into your calculator, what do you get? Give you a second. If you got 65.4 centimeters, good job. That's what I got. All right, let's move on to the next example. Here we actually have an application question. We will see more questions like this in the next lesson. We have a cube-like box that fits exactly around a soccer ball with a diameter of 10 centimeters. What's the volume of the empty space? Well, this is a little bit like composite area too, if you think about it, because we're going to be finding the volume of the box, the volume of the soccer ball, and then we're going to subtract them because the box is around the soccer ball, right? We need to figure out the empty space. So the space that's over here, up here, and all around the ball. We're saying it fits exactly, so it just touches the walls here, there, and there. And we know this is 10 centimeters, right? So if that's 10 centimeters, that means that the width is 10 centimeters. And because it's a cube, that means that this length here is going to be 10 centimeters. And then the height from here all the way down to here is also going to be 10 centimeters. So we can actually figure out the volume of the box pretty easily, because it's just, remember, the volume of a rectangular prism is length times width times height. So it's just 10 times 10 times 10, which is equal to 1,000 centimeters cubed. Well, let's figure out the volume of the ball now. Well, the volume of the ball, we need to determine what R is. R is going to be half of 10. You can figure this out because 10 divided by 2 equals R, which is just going to equal 5. So we got R is equal to 5. Just to make our lives a little bit easier, I did it up top. 4 pi, R cubed. I don't know why I did that in brackets. I didn't need to do that yet. So 4 pi times 5 cubed all over 3. If you don't have a cubed button on your calculator, you could always just multiply the number by itself 3 times. So it would be 5 times 5 times 5. Okay. So 4 times pi times 5 cubed divided by 3 should give you 523.6 centimeters cubed. Now that we know the volume of the box and the ball, what do you think we're going to do next? How about you take a guess? If you said to figure out the volume of the space, we're going to subtract them, you are correct. So we're going to take the volume of the ball, subtract, or the volume of the box, and then subtract the volume of the ball, which is 523.6. Subtract the two, you should get 476.4 centimeters cubed. And because this is a word problem, we need a therefore statement. Therefore, the volume, or VOL for short, of the empty space is 476.4 centimeters. Done. Perfect. Okay, so that's the end of this note. I'll see you in the next one. If you have questions, make sure you ask. Go through the practice, then do the quiz. Don't just skip to the quiz, because I'll know. It's pretty obvious those who are actually practicing and those who are not. All right. Best of luck.